Hello, in this lecture we'll find out the size of angle theta. In the drawing we have triangle ABC. Triangle ABC is an isosceles triangle because side CA equals to side CB. In addition, we know that this angle ACB equals to 20 degrees in its size. This angle MBA equals to 60 degrees in its size. This angle NAB equals to 50 degrees in its size. And our mission is to find out the value of angle NMB is equal to angle theta. So first of all, I will copy triangle ABC in a new page and we'll analyze this triangle ABC. Actually, this is triangle ABC that I copied from the original drawing. Angle ACB equals to 20 degrees in its size, and it's given us the question that side CA equals to side CB. That is to say, triangle ABC is an isosceles triangle. So those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one of those two angles will be defined as angle theta, then the other angle must be also equal to theta. The sum of the angles in triangle ABC must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside triangle ABC? We have those two angles, theta plus theta is 2 theta, plus 20 degrees. In total, the sum of those three angles must be equal to 180 degrees. We subtract 20 degrees from this equation, and we get that 2 theta equals to 180 degrees minus 20 degrees equals to 160 degrees. So 2 theta equals to 160 degrees. We divide this equation by 2. And finally we get that angle theta equals to 160 over 2 is 80 degrees. So angle theta equals to 80 degrees in its size. So this angle theta equals to 80 degrees. This angle theta equals to 80 degrees. So actually, those two angles are both equal to theta. So this is angle theta that is equal to 80 degrees in its size. But part of angle theta, it is angle NAB that is already equal to 50 degrees. Therefore, the missing angle must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 30 degrees in its size. Likewise, this is angle theta that is equal to 80 degrees. Part of angle theta, angle MBA, equals to 60 degrees. Therefore, the missing angle, this angle must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, this missing angle must be equal to 20 degrees. The next step, we'll focus on triangle NAB. So I will copy triangle NAB in a new page and we will analyze it. This is angle theta that is equal to 80 degrees. Angle NAB, this angle equals to 50 degrees in its size. So actually, this is triangle NAB that I call it from the original drawing. We define the missing angle as theta. The sum of the angles in triangle NAB must be equal to 180 degrees, so 50 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130, so we subtract 130 degrees from this equation, and finally we get that angle theta equals to 180 minus 130, it is 50 degrees. So this is angle theta that is equal to 50 degrees in its size. That is to say, angle NAB equals to 50 degrees in its size. This is angle ANB is equal to 50 degrees in its size. We continue to focus on triangle NAB. In triangle NAB, those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side AB equals to side NB. AB equals to NB. Those two sides are equal to each other because they are located in front of equal angles. AB equals to NB. So we'll write down here that AB equals to NB, and also here this is side AB is equal to side NB. In the next step, we focus on triangle NBA. So I will copy triangle NBA in a new page and we will analyze it. Angle MBA equals to 60 degrees in its size. This is angle theta that we calculated in the beginning of the lecture. It is equal to 80 degrees in its size. So actually, this is triangle A and B that I copied from the original drawing. We define the missing angle, this angle is theta. The sum of the angles inside triangle A and B must be equal to 180 degrees, so 80 degrees plus 60 degrees plus the missing angle that is angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140. So 140 degrees plus theta equals to 180 degrees. We subtract 140 degrees from this equation, and we get that finally that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So here this angle theta is equal to 40 degrees. Angle theta is actually angle A and B. So this is angle A and B that is equal to 40 degrees in its size. Okay. In the next step, we do a construction. That is to say, from point B, we will draw line segment BD on CA. We draw line segment BD on CA in such a way that line segment BD will be equal to BA. Okay. So this line segment BD, we draw line segment BD in such a way that BD will be equal to BA. Okay, BD equals to BA according to our construction. Yeah. BD equals to BA. Write it here also that BD equals to BA according to our construction. In the next step, I will copy triangle ADB in a new page and we'll analyze this triangle ADB. This is angle theta that we calculated in the beginning of the lecture, that is equal to 80 degrees. And again, AB equals to BB according to our construction. So actually, this is triangle ADB that I copied from the original drawing. AD equals to BD according to our construction. Yeah. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So those two sides that are located in front, those two sides are equal to each other, but those two sides are located in front of those two angles. Therefore, those two angles must be also equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. So we actually found out that angle ADB equals to 80 degrees in its size. This is angle ADB that is equal to 80 degrees in its size. Okay. We continue to focus on triangle ADB. The sum of the angles in any triangle is 180 degrees, therefore the sum of the angles in triangle ADB it is also equals to 180 degrees. We define the incident angle as theta. So in this triangle ADB, 80 degrees plus 80 degrees plus theta, in total the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta must be equal to 180. We subtract 160 degrees from this equation, and finally we get that theta equals to 180 minus 160, this is 20 degrees. Here the missing angle theta, it is equal to 20 degrees in its size. That is to say, angle ABD equals to 20 degrees in its size. This is actually angle ABD that is equal to 20 degrees in its size. So we have here the small angle ABD equals to 20 degrees in its size. The big angle ABD equals to 60 degrees in size. So the big angle the big angle is angle ABM that is equal to 60 degrees in its size. So the big angle ABM minus the small angle ABD must be equal to the missing angle MBD. So I write it down. The big angle that is actually angle ABM that is equal to 60 degrees in its size minus the small angle that is actually angle ABD that is equal to 20 degrees in its size must be equal to the missing angle that is actually angle DBM. Repeat again. The big angle ABM that is equal to 60 degrees minus the small angle ABD that is equal to 20 degrees must be equal to the missing angle DBM. So the big angle equals to 60 degrees, the small angle equals to 20 degrees, therefore 60 minus 20 is 40 degrees. So the missing angle DBM equals to 40 degrees in its size. So write it down here. This is angle DBM that is equal to 40 degrees in its size. So in the next step, we'll focus on triangle DMB, this triangle. So I'll copy triangle DMB in the new page and we'll analyze it. Just right now found out that angle DMB equals to 40 degrees. And we have already found out that angle DMB equals also to 40 degrees. So actually, this is triangle DMB that I copied from the original drawing. Those two angles are equal to each other. Again, we have the same rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side DM equals to side DB. DM equals to DB. So here, DM equals to DB. Write it down here, the DM equals to DB. This is side DM that is equal to side DB. Those two sides are equal to each other. Here we have side AB equals to side NB. AB equals to NB. Yeah. but AB also equals to BD, so we can write here that AB equals to also to BD, and from this equation BD equals to AB equals to NB, we will derive that BD equals to NB, side BD equals to side NB. Okay, side BD equals to side NB. Here, this is side DB, that is equal to side NB. And those two sides are equal to each other. In the next step, we'll join points D and N together by a straight line. And we'll focus on triangle DNB. We'll focus on the green triangle, triangle DNB. So I've copied the green triangle DNB in a new page, and we will analyze it. Angle NBD, this angle equals to 40 degrees plus 20 degrees, that is 60 degrees. And we have already found out that dB equals to NA. dB equals to NB, dB equals to NB. dB equals to NB. Yeah. dB equals to NB. This is triangle DNB that equals to the original drawing, angle NBD equals to 60 degrees, and dB equals to NB. Again, we have the same rule. That in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that also must be equal to each other. So if this angle is theta, then the other angle must be equal to theta. The sum of the angles in triangle DNB must be equal to 180 degrees, that is to say theta plus theta is 2 theta, plus 60 degrees. In total, the sum of those three angles must be equal to 180 degrees. So we subtract 60 degrees from this equation, and we get that 2 theta equals to 180 minus 60, it is 120. So 2 theta equals to 120 degrees. We'll divide this equation by 2. And finally, we will get that angle theta equals to 120 over 2, it is 60. So angle theta equals to 60 degrees in its size. This is angle theta that is equal to 60 degrees, and this angle theta equals to 60 degrees. We actually found out that inside triangle DNB, we have three angles that all of them are equal to 60 degrees in their sizes. Therefore, triangle DNB is an equilateral triangle. Okay? So I write it down here that triangle DNB is an equilateral triangle. Triangle DNB is an equilateral triangle. We know that all the sides in any equilateral triangle are equal to each other. That is to say, side DN equals to side NB equals to side DB. DN equals to NB equals to DB. Triangle NB side DN equals to side NB equals to side DB. I write it down here. That DN equals to NB equals to DB. And they also side DB equals to side NB equals to side DN. Okay, so actually we found out that from one side, side DB equals to DM. Yeah, side DB equals to DM. Okay, DB equals to DM. But from the other side, we also found out that side DB equals to side DN. Yeah, side DB equals to side DN. So we can argue that DB equals to DN. And from this equation, DM equals to DB equals to DN, we will derive that DM equals to DN. DM equals to DN. DM equals to DN. Yeah, side DM equals to side DN. In the next step, we'll focus on this side of the straight line CA at point D. Okay. So, which angles we have on this side of CA at point D? We have this angle that is equal to 80 degrees in its size. This angle is one out of three angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees, of course. And this is the missing angle. So this is the straight line CA, and those are the angles that we have in this side of the straight line CA at point D, 80 degrees plus 60 degrees plus the missing angle. 80 plus 60 is 140, plus the missing angle, 140 plus the missing angle must be equal to 180 degrees, according to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. Okay, the sum of the angles on this side of the straight line CA at point D must be equal to 180 degrees. So 140 minus 40 is 180, exactly according to the rule that I mentioned. So the missing angle must be equal to 40 degrees in its size. So this angle the angle MDN must be equal to 40 degrees in its size. Okay, so in the next step, I will copy triangle MDN in a new page and we will analyze it. We just now found out that angle MDN, this angle equals to 40 degrees. And we have already found out that dm equals to dn. Yeah, dm equals to dn. dm equals to dn. Write it here that dm equals to dn. Again, the same rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is theta, then the missing angle must be, then the other angle must be also equal to theta. The sum of the angles in triangle MDN must be equal to 180 degrees. Theta plus theta is 2 theta plus 40 degrees. In total, the sum of those three angles must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divide this equation by 2, and finally we get that angle theta equals to 140 over 2, it is 70 degrees. So angle theta equals to 70 degrees in its size. That is to say, this is angle theta. That is equal to 70 degrees. That is to say, angle DMN equals to 70 degrees in its size. So, actually, this is angle DMN. This is angle DMN that is equal to 70 degrees in its size. This is angle theta that we calculated here. Angle DMN equals to 70 degrees in its size. So angle DMN that is equal to 70 degrees minus the small angle DMB that is equal to 40 degrees must be equal to the missing angle theta, that is the angle that we are looking for. Again, the big angle DMN minus the small angle DMB must be equal to the missing angle theta. So I write it down. The big angle that is actually angle DMN that is equal to 70 degrees in its size minus the small angle that is actually angle DMB that is equal to 40 degrees in its size must be equal to the missing angle that is actually angle theta, and the angle theta it is also angle NMB. So I repeat again, the big angle DMN that is equal to 70 degrees in its size minus the small angle DMB that is equal to 40 degrees in its size must be equal to the missing angle theta, that is the angle NMB, that is the angle that we are looking for. So the big angle is 70 degrees, the small angle is 40 degrees, so 70 minus 40, it is 30 degrees. So we found out that the missing angle theta, that is actually defined as angle NMB, it is equal to 30 degrees in its size. So the answer to this question is that this is the missing angle theta, angle NMB, that is equal to 30 degrees in its size. In the next step, I will summarize the lecture. Okay. So in this lecture, we found out the size of this angle theta, that is actually angle NMB. It is given us in the question that side CA equals to side CB in triangle ABC. That is to say, triangle ABC is an isosceles triangle. Those two sides are equal to each other. In addition, you know that this is angle ACB that is equal to 20 degrees in its size. We also know that angle NAB equals to 50 degrees in its size. This is angle MBA that is equal to 60 degrees in size. Again, we have to find out the size of this angle theta, that is actually also angle NMB. So first of all, I copy triangle ABC in a new page and we analyze this triangle ABC. this is triangle ABC that I copied from the original drawing. CA equals to CB. This angle is CB equals to 20 degrees. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other according to the rule that I mentioned. So if one angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside triangle ABC? We have theta plus theta is 2 theta plus 20 degrees equals to 180 degrees. So 2 theta plus 20 degrees equals to 180 degrees. We subtracted 20 degrees from this equation and found out that 2 theta equals to 180 minus 20, it is 160. So 2 theta equals to 160 degrees. We divided this equation by 2. And finally found out that angle theta equals to 160 over 2, that is 80 degrees. So this is angle theta is equal to 80 degrees. Those two angles are both angle theta that is equal to 80 degrees in its size. Okay, so here we have those two angles are both angle theta. So this is angle theta that is equal to 80 degrees, but part of angle theta is already equals to 50 degrees, therefore the missing angle must be equal to 30 degrees. In order to complete the size of this angle theta to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is also angle theta that is equal to 80 degrees. But this angle MBA, also, it is already equals to 60 degrees. It is part of angle theta. Therefore, the missing angle here must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here, angle CBM, must be equal to 20 degrees. In the next step, we focused on triangle NAB. So I copy triangle NAB in a new page, and we analyze it. This is triangle NAB that I copied from the original drawing. Angle NAB equals to 50 degrees in size, and angle NBA equals to 80 degrees. Okay, NAB equals to 50 degrees, NBA equals to 80 degrees. We defined that the missing angle is theta. The sum of the angles in triangle A and B must be equal to 180 degrees. So 50 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those angles must be equal to 180 degrees. 50 plus 80 it is 130. So we subtracted 130 from this equation. So angle theta equals to 180 minus 130, it is 50 degrees. Here, this is the missing angle theta that is equal to 50 degrees in its size. So angle A and B equals to 50 degrees in its size. This is angle A and B that is equal to 50 degrees in its size. We continue to focus on triangle A and B, this triangle A and B, this triangle A and B. Those two angles are both equal to 50 degrees, and we have the rule that in front of equal angles in the triangle there are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side AB equals to side NB. Again, AB equals to NB. Here, roll down here. That AB equals to NB, and here also side AB equals to side NB. Okay, so in the next step, we focus on triangle A and B. This triangle A and B. So I copy triangle A and B in a new page and we analyze it. This is triangle A and B that I copied from the original drawing. Angle MAB equals to 80 degrees. Angle MBA equals to 60 degrees. MAB equals to 80 degrees. MBA equals to 60 degrees. And this is the missing angle, angle theta. The sum of the angles in triangle MBA must be equal to 180 degrees. So 80 degrees plus 60 degrees plus the missing angle theta, in total they must be equal to 180 degrees. 80 plus 60 is 140. So we subtract 140 degrees from this equation and found out that angle theta equals to 180 minus 140 is 40 degrees. So angle theta equals to 40 degrees in its size. That is to say, angle A and B, that is angle theta equals to 40 degrees in its size. This is angle A and B, that is equal to 40 degrees in its size. Okay. In the next step, so from point B, we go line segment BD in such a way that line segment BD will be equal to BA. Okay, we construct line segment BD in such a way that BD equals to BA. Repeat again. BD equals to BA according to our construction. Then I copy triangle ADB in a new page and we analyze it. This is triangle ADB that I copied from the original drawing. This is angle theta that we calculated in the beginning of the lecture, that is equal to 80 degrees in its size. And we found, according to the construction, AB equals to DB. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. But this angle is equal to 80 degrees, therefore the other angle must be also equal to 80 degrees. So actually angle ADB, this angle ADB equals to 80 degrees in its size. This is angle ADB that is equal to 80 degrees in its size. We continue to focus on triangle ADB. The sum of the angles in triangle ADB must be equal to 180 degrees. We define the missing angle as theta. So 80 degrees plus 80 degrees plus theta, in total they must be equal to 180 degrees. 80 plus 80 is 160. So 160 plus theta equals to 180 degrees. We subtracted 160 degrees from this equation and finally found out that angle theta equals to 180 minus 160, it is 20 degrees. So the missing angle theta is equal to 80 degrees in its size. That is to say, angle ABD equals to 20 degrees in its size. Here, this is angle ABD that is equal to 20 degrees in its size. Then, actually have here the small angle ABD equals to 20 degrees in its size. The big angle ABM equals to 60 degrees in its size. So the big angle ABM minus the small angle ABD must be equal to the missing angle MBD. Repeat again. The big angle ABM that is equal to 60 degrees in its size minus the small angle ABD that is equal to 20 degrees in its size must be equal to the missing angle DBM. So 60 minus 20 is 40. So the missing angle DBM, this is the missing angle DBM that is equal to 40 degrees in its size. Then we focus on triangle DMB, so I copy triangle DMB in a new page and actually focus on triangle DMB and I copy triangle DMB in a new page and we analyze this triangle DMB. This is triangle DMB that I copied from the original drawing. We just right now found out that angle MPD or DBM is the same, is equal to 40 degrees in its size, and we have already found out that this angle DMB also equals to 40 degrees in its size. So those two angles are equal to each other, and according to the same rule, that in front of equal angles in the triangle there are equal sides, we get that those two sides that are located in front of equal angles must be equal to each other. That is to say, dm equals to db. Again, dm equals to db in triangle dmb. dm equals to db. Yeah, dm equals to db. And also here, dm equals to db. Okay. And here we have, according to this equation, AB equals to NB, AB equals to NB. So here AB equals to NB. But AB also equals to BD. So you can write here that AB equals to BD. And from this equation, BD equals to AB equals to NB, we will derive that BD equals to NB. Here BD equals to NB. Here also side BD equals to side NB. Okay? In the next step, we focus on triangle. Actually, we join points D and N together by a straight line. And then we focus on the green triangle DNB. So I copy triangle DNB in a new page and we analyze it. The size of angle NBD, this angle, it is 40 degrees plus 20 degrees, that is 60 degrees. And we know also that DB equals to NB. Here, DB equals to NB. So this is triangle DNB that I copied from the original drawing. I repeat again that angle NBD equals to 60 degrees in its size and DB equals to NB. Those two sides are equal to each other. Again, according to the same rule, that in front of equal sides in the triangle there are equal angles, we get that those two angles that are located in front of equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle DNB equals to 180 degrees. So which angles we have in triangle DNB? We have theta plus theta is 2 theta plus 60 degrees. In total, they must be equal to 180 degrees. We subtract the 60 degrees from this equation. And finally, we found out that 2 theta equals to 180 minus 60, it is 120. So 2 theta equals to 120 degrees. We divided this equation by 2, and finally we found out that again theta equals to 120 degrees over 2, it is 60 degrees. So this again theta equals to 60 degrees, and this is again theta that is also equal to 60 degrees. So I actually found out that inside triangle DNB we have three angles, that all of them are equal to 60 degrees in their sizes. Therefore, triangle DNB is an equilateral triangle. Repeat again. Triangle DNB is an equilateral triangle. And we know that all the sides of any equilateral triangle are equal to each other. Again, all the sides of any equilateral triangle are equal to each other. Therefore, in the equilateral triangle DNB, side DN equals to side NB equals to side DB. dN equals to NB equals to DB. You can write here also that dN equals to NB equals to DB, and here also dN and DB equals to dN equals to NB. Okay. So from one side, dB equals to dm. We already found out that dB equals to dm, so we can write here that dB equals to dm. But from the other side, we just right now found out that dB equals to dn. So we can write here that dB equals to dn. Okay? So we found out that dm equals to dB equals to dn, and from this equation, we will derive that dm equals to dn. Okay? dm equals to dn. dm equals to dn. We can write here also that dm equals to dn. Okay. In the next step, we focus on this side of the straight line CA at point D. Which angles we have on this side of CA at point D? We have this angle that is equal to 80 degrees. This angle is one out of three angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees, plus the missing angle. Okay, those are the three angles that we have on this side of CA at point D. Again, this is the straight line CA, and point D, we have 80 degrees plus 60 degrees, it is 140 degrees. 140 degrees plus the missing angle, in total they must be equal to 180 degrees, therefore the missing angle must be equal to 40 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. 60 degrees plus 80 degrees plus 60 degrees is 140 degrees, and 140 degrees plus 40 degrees, it is 180 degrees. That is the sum of the angles on this side of the straight line CA, at point D. So this angle equals to 40 degrees. That is to say, the missing angle here is angle DMDN, that is equal to 40 degrees in its size. So I copied triangle MDN in a new page, and we analyze this triangle MDN. We just right now found out that this is triangle MDN that I copied from the original drawing. We just right now found out that angle MDN equals to 40 degrees, and we have only found out that DM equals to DN. Here, DM equals to DN. Okay. Those two sides are equal to each other. Again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DMN, it is equal to 180 degrees. So theta plus theta is 2 theta plus 40 degrees. In total, 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation, and we found out that 2 theta equals to 180 minus 180 minus 40, it is 140 degrees. So 2 theta equals to 140 degrees. We divided this equation by 2, and finally found out that angle theta equals to 140 over 2, it is 70 degrees. This is angle theta, it is actually, this is angle theta, is equal to 70 degrees, but angle theta is angle DMN. So angle DMN equal to 70 degrees in its size. So the big angle DMN, it is equal to 70 degrees in its size. Minus the small angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle NMB. Again, the big angle DMN, that is equal to 70 degrees in its size, minus the small angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle, that is angle theta, that is defined also as angle NMB. I'll repeat again. The big angle DMN, that is equal to 70 degrees in its size, minus the small angle DMB, that is equal to 40 degrees in its size, must be equal to angle theta, that is actually angle NMB, that is the angle that we are looking for. So the big angle is 70 degrees, minus the small angle, that is 40 degrees, must be equal to the missing angle theta. So 70 minus 40 is 30 degrees. So finally we found out that the missing angle theta, that is also defined as angle NMB, is equal to 30 degrees in its size. Here, this is angle theta, the angle that we are looking for. It is also equals to angle NMB, and this angle theta equals to 30 degrees in its size. Okay? Thank you very much.